Hypothesis test for difference in p-hats. Hypothesis tests can be used when given two sample proportions. To get an accurate estimate of P1 minus P2, we pool the data. We call this pooled data p-hat C.
Formula for pooled data is shown below.
In a hypothesis test for difference between proportions, we use a z-test statistic. The formula for this is shown below.
Like all hypothesis tests, there are several conditions that must be followed in order to ensure that the test will carry out fairly accurate results. The conditions are 1. SRS. The two samples are in SRS from their respective populations or are in two groups in a randomized experiment. 2. Normality. N1 PC, N1 QC, N2 PC, Q2 PC are greater than or equal to 10. 3. Large populations, N, are greater than or equal to 10N1 and 10N2. Therefore, the standard deviation follows normality.
The purpose of a hypothesis test is to test a claim. In the difference between two proportion hypothesis tests, we compare proportions that are given with numerical data. We do hypothesis tests by following a series of steps. State the claims, plan by identifying your significance level and the names that you will use, analyze your data by making the necessary calculations, and conclude by summarizing your results.
Look at an example. A group of researchers designed a survey to compare the proportions of adults who came to work without eating breakfast in two low-income working occupations. An SRS of 80 adults from Workplace 1 found that 19 had not eaten breakfast. At Workplace 2, an SRS of 150 adults found that 26 had not eaten breakfast. More than 1,500 adults attended each working occupation. Do these data give convincing evidence of a difference in the population proportions? Carry out the significance test at alpha equals 0.05.
List your conditions. P-hat1 equals 0.2375. P-hat2 equals 0.173. P-hat-C equals 0.1957. Then list your claims.
The formula for z-score is shown below. Plug these numbers into the formula and then use StatTest 2 proportion z-test to find the p-value, which is 0.2427.
The p-value is greater than alpha, therefore we fail to reject the HO. We do not have statistically significant evidence to reject the claim, meaning that the populations do not show convincing evidence of difference in population proportion of adults that eat breakfast before work.